So today I'm going to show some functionalities of HyDraw CAD 2021, and as always, I try to make some new applications. So so today I want to draw a diagram for a valve stand. So valve stand usually are used in the industrial hydraulics. Well, I think I have an image taken from one of my customer in Italy. This one. So valve stand is basically just a series of manifolds all connected with lot of valves on top, used mainly in heavy industrial applications. That with this layout they can easily be maintained, and of course the size is big, so they are not well suiting mobile application. The diagrams are particular in this case. Today we'll describe a diagram for one of the valve stand. So we'll see some HyDraw CAD commands when drawing a schematic for a hydraulic industrial application. So let's start. Let's go back to HyDraw CAD environment. I have started with a blank drawing. On the left, we have all the library of symbols. And since the diagram will be pretty large, let me start with placing an A1 title block. So by moving to the System tab, you can insert title block and select A1. And here I have my frame. So normally this kind of hydraulic diagrams are in multi-page. So I'm thinking of having other meetings, other webinars about how to manage multi-page. So now we focus only on this page. We'll discuss about multi-page in different webinars. So usually you have this kind of diagrams are similar to what people do with the electric diagram. So we have a P line, a tank line that usually start from one page and go on to the other page. And let's say that we need some shut-off valve here. So we can find the symbols directly in our library. So we can look for a shut-off valve, line mounted, and we can just insert a symbol and place it in the drawing. So we can place symbols directly on top of connection lines, and symbol will be automatically breaking connection line into two pieces. And we can describe the shut-off valve by manually putting all model data information, or we could go into our online database or Fluid Power Tools database or local database. And in Fluid Power Tools, we can find items from several manufacturers. By the way, let's say that we just run a search, generic search. I have some then shut-off valves in my database, and I'll use them in my system. Now the search is very generic. There are a lot of ball valves in our online database, so this is taking a few seconds. I should have filtered by. So here we have some manufacturer, and we can sort by flow rate, by pressure, type, manufacturer, and so on. And we can open a datasheet. Let's say that for this application, we use this one. I'll jump to a different one later in my application. If I need another one, let's say for the tank line, I can just right-click, copy, start point and end point, and press enter. So automatically I have item 1.1 and 1.2. Since these lines will start from a different page, we can add the jumping reference. So jumping reference is just a small symbol. So the name is maybe P1 and is coming from the first sheet. And also we do the same one here, T1 coming from the first sheet. And then we go here. This will be called P2 and go to the third sheet. Let's assume that we are working on the second sheet, and so on. T2 is on the third sheet. But our schematic will concentrate in the center of our diagram. So let's start building our valve stand schematic. Usually we have a pressure line. So we start with a pressure line connected to the pressure line, and let's position it here. And then we make a tank line here. Now we start placing our valves. So we will put, in this case, sandwich mounted valves. Usually valve stand have different sizes of industrial valves. So we can have NG25, NG32, NG6, NG10. So we will do a small mix of this application. So let's start searching for some symbols, and then I will jump to search for component data. So all the symbols are arranged into the library. So directional control valve are inside the directional control valve. We want a stackable symbol. A stackable symbol folder are symbols that we want to stack up. Flipped are symbols that we stack down. So I want a stackable symbol flipped. I want, let's say I'm looking for an NG16. So I need a solenoid controlled pilot operated. DO7, so that's an ISO 4401 NG16 or NG25 or NG32. Let's say that we need an internal pilot, internal drain, double solenoid, spring centered, and here we can select the spool that we need. So let me take this one, which is interesting. This one has a position where P is going to B, but the other position is basically making a regenerative circuit. So this one will be applied to a cylinder where we have a position where we do a regenerative circuit. If we want to apply model data to this component, we can select from the library, and we can look in Fluid Power Tools if there are items linked to that. So at present, I can see some ethos valve, which is fine. I need an NG16, so the 440107. We can look at the datasheet as well. And let me click OK. So in this case, I want to use ethos components. Let's find the PO check sandwich module. So now, instead of looking for symbols, I will go to the search in Fluid Power Tools. So searching in Fluid Power Tools allows us to do a lot of different search. So let's say that we look for a Z2S, which is the pilot operated check valve for Rexroth. So in this case, we will find a lot of different sizes. We need a larger size, Z2S 16, which is basically the size 16. So in this case, as you see, we have pilot and drain. This is fine, but we don't want Bosch Rexroth, so let's stay with ethos. So we select the symbol, and we can show linked model to that symbol. So in this case, HyDraw CAD will give us equivalent components for different manufacturers. So I take a JPR 212 and double click on the item and position it in the drawing. So when we place an item from Fluid Power Tools, as you see directly, we have the datasheet linked here. In addition, I want a flow control valve. So let's say that we need a Z2FS sandwich module, always a 16 size. We need, let's say that we take a meter out application. So this is the symbol. And we show the linked models. And in this case, we have only Rexroth, and let's stay with Rexroth. We could later do other diagrams. So this one has leakage. I don't, I'll do some search later for a different component. Let me do that. So I don't like this with the leakage port. I go back to my search, and I need a symbol without leakage port. Let me search directly in my library. I need a flow control Sorry, I need a stackable valve, flipped, and G7, flow control, and I need the metal out. This one is the symbol. So now I found the symbol. Let me search in the database what I have available. This will find Eaton, Ethos, Parker items. Let's stay with Ethos JPQ212. Of course, if you are familiar with model codes, you can directly find the item that you need by model code. So now I want to build a stack of these items. So we can use the stack command, select all the items, and the stack. In this case, I want to stack down. So these items behave like a single element, and we can also move the stack just by moving one item of the stack. Now, since the chance to use this particular circuit is very high, let me show you how to build a subsystem from this. So subsystems are very handy because you can store part of diagrams to use in other application, in other system you make. So to make subsystem, you move to the subsystem tab. To enter in edit mode, you just click on the edit library editor. And here we can save subsystem. Let's say that this is a stack module, G16. I have other elements here, so we can just right click, add new. We select the items that we want to add. And we want to specify the insertion point and select the insertion point. So in this way, HyDraw CAD is adding to my subsystem library a new stack that I will be able to use later in other application. So this is my first stack. Let me move to the second one. Let's say that this stack is used at the end of my valve stand. So I can double click and place my position here. So as you can see, I have positioned as a group. So now this is really placed as a subsystem, but I did that by mistake. I don't want it. We could explode this entity in the drawing, or we can just delete and check the explode subsystem. When we enable explode subsystem, it means that we want to use these items as loose parts in our diagram, and this is what we want to do, because later we may need to change some valves. So as you can see, these items became automatically 2.2, 3.2, and 4.2 because they have the same model code as the previously saved items. So one important information is when we save subsystem, the subsystem will store all the model data linked to the source subsystem. So if the subsystem is made without model code, the subsystem will have empty model code. But if we store a subsystem with part numbers model code, the subsystem will include exactly the same part numbers in the subsystem. Let's move to the second stack, and in this case, let's go for a NG6 size. So we don't work anymore on subsystems, we work on components. I'm going faster. I want Z2FS6, a flow control valve. And let's say always meter out. And let's say that this position has no PO check. So we go back to the search and look for a 4W6J. And we take always Bosch Rexroth in this case. Not the A version, I need the 3 position. It is possible to position directly the symbol on top of the other, or really you can use the stack command. The advantage of using stack command is that it will really tie one symbol to the other. It is possible to break a stack, so you can just select, right click, and use the unstack command. So in this case, you will be able to move items of the same stack and position other items. So let's say that we need a pressure reducing valve here. And let's say that we don't know the model code of the pressure reducing valve. So we reset the search and we do a search by pressure reducing valve. We need a sandwich module, so a stack module, and we do a search in our database. And here it is finding a lot of manufacturers. Let's look for, let's take Eaton. We take DGMX. This is fine. I need the other position. So this looks good. Oh no, that has a drain. So sorry, I need this. Let me find this one. This is okay. That was a different size. Again, I can make the stack of this element. So I can use the stack and stack up and down. Now I can move. Like I did earlier, I could save my stack in my subsystem library. This is done very handy. I am happy for this improvement we made with the 2021. We really made much easier the interactions with the library in terms of new symbols and subsystems. So we just add, select, and specify the insertion point. We have also a very good build symbol mode I showed during my last webinar last month. And this is working very, very nice too. And you are very fast when making new symbols. Let's say that these items I copy. So using AutoCAD commands, copy, I position another element here. But in this case, I don't need the reducing valve. So in this case, I need to break my stack. So delete, and I make a new stack here. Up. Let's put the last element. Let me move these items on the right. Let's take an NG10. Let's move. And I can take, or I can go into my library and take an NG10 stack already made. Let's say this one is fine. This one had been made during another webinar in my system. Now our valves will be connected to the pressure line. So we start making the connection. As you see, I have selected the internal pilot valves NG16, so I need to close X and Y. So to describe that you don't need X and Y, we use the terminator. So terminator will be applied to X port and Y port. And the same we do on the last element, X port and Y port. Now we connect some elements. So we need a pressure line going from our P to the pressure. And press enter to repeat the last command. This will work for all the commands that you use. And the last one is this. I need to extend this. To extend the lines, you just select and stretch the vertex. And we make tank lines from T to tank. Enter, and we go on. NG10 can have 2 or single tank. In this case, we have TA and TB. That is fine. Now we make working lines. According to ISO 1219, working lines have a different color. They belong to a different layer, and we have the working line. And we start from A. And let's say that on top we will have a cylinder, so let's extend a bit. We could also copy entities, so using the AutoCAD functionality copy, and we start from B and paste. Now we want to describe our valve stand manifold. So basically we will draw a rectangle that will cross connection lines, breaking our system into external ports. Let me save my diagram. And let me start making the envelope. So the command is called envelope, and we create an envelope that is crossing connection lines. Usually when I have sandwich mounted valves, I make the envelope outside. Then if you want, you can really put it directly here so the representation is good, but that is really how you want to describe the valve stand. This is the item for the manifold, so we put it on top left corner. And if we don't like the balloon, we can just change it one by one with a double click on the property manager. So we can change to hexagon. If the item ID is too small, although you could change the settings for your application, but there may be some things that you want to highlight more, you can go to the System tab and change height to a text. And we can make it 5 mm. And this is changing just the text for that particular item. As you can see, when we made the envelope, automatically we have broken the connection line into external ports. And now we can start defining the size of this external port. So let's say that we have 250 liters per minute on this port, and that's a pressure port. So we want to select library. And as you can see, we are searching for 250 liters per minute. We want a SA flange, and that's a pressure line. So let's say that we reach maximum 300 bar. So our system will pick the size in the library that is defined for the 250 liters per minute. If you are not okay with the size, you can change the values in the library manager that are matching those flow rates, and we can select a different size. Let's say that's a 2 code 62 inches, and that's the P1. And the opposite P2 has the same size, so we can use a smart command that is called copy. So copy from this to the other size, and we can click OK. This is applying the same size to the other port. The name can be changed in the property manager, or with a double click, you can just type in the name of the port, T2. It's always better to select the size from the select from library command, although you could type in whatever you want. So if you type anything in the port size field, this will be displayed. But really it's handy, and my recommendation is select from library. If you don't find what you want, you can type in and define the ports that you need and save to the library. Let me search, that's a return line, and I want 2.5 code 61. And as I did for the P port, I copy this one to this one. Okay, and that is my T1 port. Now let's focus on A, B ports. So that's my A1, B1, A2, B2, and B5. As we did for the other size, we could select a different size. Let's say this are 3x4 BSP for the NG16, which we copy to all the NG16 ports. While the NG6 will be, let's say, 3x8, and we can copy. Okay, and we keep alpha and inch for the NG10. We are good. Usually for valve stand, we have test points for all the ports, because really the configuration is that we have valves that will control how the actuators will work, and we need to be able to measure pressure on each line. We have a smart command in HyDraw. It is configurable in the application settings, a gauge port. So here you can define the standard size for a gauge port. I normally use a G1x4 BSP port, but you may select a different size of ports, and the distance, standard distance from the port. So the command in this case, I will run twice because I will want to create a gauge port on all the A port. So I select all my A port, enter to confirm selection, and I follow what is described in the command line. I need an open symbol to the left. So this is adding all the test point to my A ports. Enter to repeat the last command, and I do the same on the other ports. Always open to the right. Let's say that we need some test point. So we can go to the library and close the library search. And if you don't need the edit mode, you can close the edit mode. That's okay. And I have my mini mesh here. And I double click and can place my mini mesh on top of a connection line. In my library, I have defined a mini mesh, so I can go and search in my database and find a IFM mini mesh. So that now it's very easy. I can just copy this item from here to here, enter, and automatically I have all the balloon and the item ID. So it will be easy to make then the part list. Let's say that we need some pressure transducer. So we go again in the search in Fluid Power Tools, and we look for a PT54. That's a IFM pressure transducer. And with a right click, we can view the datasheet. And we can place it in the drawing. So with a double click, and we could region. With a double click, we can rotate the symbol at insertion. So from command line, we can do a rotate left, so we can place our symbol in the drawing. This was not a very good example because actually the preview is showing not rotated, but then as you see, the text is always automatically rotated when it's placed in the drawing. Let's say that this has a hose, so we can take a connection line here, and we can break the connection line with a hose. So we can go back to the library and find the hose component type, hose, and we can place the symbol in the drawing. As you can see, the hose has a different balloon. So in this case, it's a rectangle, because you have the possibility to manage hose assemblies separately from components. That's fine. Now, let's say that I don't want the hose to be in my part list, so I exclude from part list, and I just do a copy. Let's say that between my valve and my actuator, which I'm going to place, so let's look for a cylinder, double acting, and I place my cylinder here. And I want to exclude from part list, and I want to copy. Let's say that here we have 2 cylinders, here we have only 1. And now we make connection. So to make connection, so far I always made the manual connection. So manual connections means you make the connection that you select a connection type and click as many times as you want to make the connection, and then you finish the connection on another symbol or on another connection line. The automatic connection mode, auto connect, will just allow you to select the start point and the end point. enter to repeat the last command, start and end. For these simple linear diagrams, it's very handy. For more complex item, I would recommend that you make a connection manually. Sometimes you may have this strange behavior. This is because I didn't pick correctly the port, but you can just, well, it's easy if you redo the connection. Or if you don't like the solution of the connection line, you can use the stretch command. Stretch command allows you to change position or add the segments to a connection line if it is needed. You can also use stretch to remove those band from the connection line. In this case, if you pick a wrong item, just take the insertion point, connect, and use always the stretch to simplify the connection line. Sometimes you may fight against the AutoCAD snap to grid, which I have switched on. Remember, F9 will remove the snap to grid. F3 will turn on and off the snap to object. So remember, this will be handy. If you get familiar with F9, F3, then you will become very fast with doing operation that sometimes you struggle with. Let's put some shut-off valves on these lines. I have in my library. So basically, so far I have always worked with items that are in the online database, fluidpowertools.com. But you can build your library with the data that you want. As an example, I have in my library. So I'm searching in my database. Let's say I need a shut-off valve and search. So I have a lot of Pister components. And in this case, I take, let's say, this is a 3x4. So let me take a 3x4. This item, if I'm not satisfied, I can right click and view the datasheet to view the description of technical information of my Pister datasheet. In this case, the datasheet is physically and locally in my machine. It could be in a server, it could be in internet, and it is linked to the components directly through the library manager. So library manager allows you to link datasheet and model data to symbol for what you want to manage internally in your database. So anything you put in the drawing environment, like my PT 5400, I can save to my library. So now this items becomes part of my library. And the same happens to each valve. I can save to my library. So next time I can just search in my corporate database. I can do my search, for instance, for the PT540, and it will find exactly the same symbol. The only thing that is not preserved when you save to your library is the link to the datasheet. So when you save to your library, the link with the datasheet will be broken. You can link items in the library using the library manager. So under components, we can go to the model data view. Here you have all the components that you have. This is an example library of items. I will need to find a PT540. And as you can see on the right, there is no document. So what I could do is I could go to my drawing environment, take the datasheet that was coming from Fluid Power Tools. That's an opportunity. Or you can download the latest from IFM datasheet. But let's say that I take this one, I save as, and position into my repository. So my repository is just a folder in my library, IFM, and that's my datasheet. PT5, it's already there, so that's not a problem. Save. Then I go to the library manager and I want to link that datasheet to my component. I link the document. I need to first load the datasheet. So to load the datasheet, you click Add New, you select the folder and take the datasheet, ENUS, and you define the category. This is an IFM. If the category is not there, you can create new categories, IFM, and select it and click OK. So in this way, we have loaded all the datasheet for IFM in our database. And now I can just link my PT5400. So in this way, I have in my database, I have put information coming from fluidpowertools.com, saved into my library, and linked with my datasheet. By doing that, when I do a search in my corporate database for the same PT540, now I will have also the datasheet linked. And if I place the symbol in the drawing, it will come with a datasheet link. In this case, the link is made in the library. There are several ways to speed up the process of library creation. We did some webinars months ago. We will make more in the coming months about library management. But this is very briefly how you can create a component in the database and link a datasheet to your library. I'd like to put more items and more descriptions, but we are running short of time. So let me try to build a part list for this item. As you see, we started with flow shut-off valves, so they are item 1. And then we went on 2, 3, 4, and so on. So the number is growing according to which item was placed first. But you have the possibility to change numbering for all components in a diagram. And the command is under System tab, is called Item. So Item ID can be run on a selection of item. And now let's make all items. And I want to start numbering from 100. So in this case, I'm massively renumbering all items starting from 100. So the logic to renumber is always from left to right. So the most left will be 101, 2, 3, and 4, and so on. If there is a manifold, this will take the lowest number in general. Because when we renumber and there is an envelope, usually that is a container. So usually this has the lowest numbering. Of course, if you don't like, you just change. You select the manifold and you can change the numbering. Or you can renumber just by selecting different, a small subset of components. The numbering will be able to group identical items, as you see, 1031, 104, 105, and so on. If ID is overlapping, you can just move the ID. And so on. When we want to make a part list, we can just run the part list command on the selection. If you want to select the entire diagram, just type all. And this will select all the diagram. And here we can define the part list format. Let's stay with HyDraw default, but really you can make a lot of different format. Those are made during training and during other demonstrations. So let's take the HyDraw default and click next. And here we have a preview of our system. We forgot to put a model code on the manifold. So let's say that the model code is VEST webinar manifold 1, and the manufacturer is VEST. By clicking update, all the information that we type in here will go to the corresponding symbol in the drawing. The part list can be exported to Excel or can be placed into the drawing. And this is our part list. You can control size of the part list, header, and which attributes are in the part list. Once the part list is created, you can later modify it, and you can delete items or you can type in text. What I recommend is always, in any case, do the change directly in the item. So for instance, the model code is different, let's say VM1234. Now that's a new model code. The part list will require an update. In yellow, you see the line that is involved by this update requirement. And in red, you have the text that is going to change. To update a part list, you right click and click update part list. And this is changing the model code on the part list. For a valve stand, it's very nice to have a list of external ports. So we can select ports, select all the manifold, and select the type of external port list, next, and we can place our port list directly on the drawing. Each list can be exported to Excel. So in this case, we have a list of all the different sizes of our valve stand ports. And again, you can customize it. So we have just 3 minutes. I see a question from a user here. So the question is this software a standalone software or a supplement to AutoCAD? So HyDraw CAD is, although it is using an AutoCAD engine, because if we look at the information, license info, we see that we have the Autodesk logo here. You don't need AutoCAD to run HyDraw CAD. We license an AutoCAD OEM. Technically, it's an AutoCAD OEM. Basically, it has all the AutoCAD functionalities, but packed in a software to make diagrams. So this can replace all the AutoCAD licenses because it does not require an additional AutoCAD license. The file format is a native DWG, save as. It's a DWG. You can save also in previous format. It will work always fine. You can save into the XF. By doing that, you will lose the attribute. So please save to the XF only if you need to exchange information with some of your customer or colleagues. And you can open natively any DWG file because the engine is pure AutoCAD. If there are any other questions, just feel free to post. I think we have just 1 minute left, so for today, I think it's okay. Let me just plot. So, I mean, we made all the effort. Let's go to the A1 and let me do a plot of my system. So in this case, I will have my diagram well configured, and I can make a PDF or plot to my printer. I turn it over to I see another question. Okay. The question is, can you list the hydraulic hose and pipes with length on them? Yes, it is possible. I'm sorry, we had no time to do that. That's a new functionality also in this version. Let me quickly try to show. I think it makes sense. So we may do maybe a dedicated webinar on pipe and tubes. So basically, let's say that let's do here. I need to put some name to the cylinder port, let's say A and B. Okay, so let's say that this lines going from A1 to A is a pipe. So we make it a pipe. We give an ID, let's say A1, that's the ID. And we go to our library and select, let me take a schedule standard, let's say standard schedule that was a 3x4. Okay. So as you see, the information is shown in the connection line, and you can customize the way the connection information are shown. When we make a connector list, for this item, we have the nominal size with the routing from to, so from 100 A1 to A port, and the line ID is A. The same happens if we define a hose. So for the connector type hose, I'm showing just data from my library. So here, let's take a NBR ride. Let me take it. That's an Intertraco item, and the line ID is let's say 45. So we can make the connector list also for hose in the drawing. And here we have the cut length. So the cut length is an attribute that you can fill in, and that will be blank in case you want to later fill in. Otherwise, you could apply the information directly in the model data on the right. So that is up to you.